This is the video on cube roots. It's a Vedic math way. Sutra is mostly by observations. Okay, let us continue. Okay, let's look at outline here. We would discuss these topic in various sections. First is first principles, then some more. Okay, continue. What's cube root here? We'll discuss first principles first. Cube is when we multiply a number by itself twice, we get a cube of that number. Let's continue. If n were a measure of the length, volume of a cube of length n is n cubed, because n cubed represents volume of a cube of length. We call it a cube of length n. Thus, n cube is called n times n times n. We multiply n by itself twice more. Okay, let's continue. That's from Glover's book. Okay, let's continue here. A cube root is the reverse of cubing. To determine cube root of n, we need to find the length of a cube with the volume of n. A cube root of n is solution of the equation x cubed equals n. Let's continue. Let's discuss first principles as they relate to cubes and cube roots. Let's continue here. To study first principles, look at the first 10 cubes given below. Let's continue here. If n, here's the, for n 1, 2, 3, 4, 5, and up to 10, I have these cubes. For n equals 1, cube is 1. For n equals 2, its cube is 8. A cube of 3 is 27. A cube of 4 is 64. Cube of 5 is 125. Cube of 6 is 216. And that of 7 is 343. And cube of 8 is 512. And cube of 9 is 729. And cube of 10 is 1000. Let's continue here. So let's make observations here. When ends in 1 and cubed ends in 1. Okay, when n ends in 4 and cubed ends in 4. When n ends in 5 and cubed ends in 5. When n ends in 6, its cube also ends in 6. When n ends in 9, its cube ends in 9. And when n ends in 0, its cube ends in 3 zeros. Okay. When n ends in 2, its cube ends in 8. And when n ends in 8, its cube ends in 2. So look at symmetry here. 2, 8, and 8 and 2. 8 plus 2 is 10, and 8 plus 2 is 10. 2 plus 8 is 10. Okay. When n ends in a 3, its cube ends in a 7. When n ends in a 7, its cube ends in a 3. 7 plus 3 is a 10. 3 plus 7 is a 10. 3 plus 7 is a 10. Let's continue. When n ends in a 2 and cubed ends in 8 from here. When n ends in a 3 and cube ends in a 7 from here. When n ends in a 4 and cube ends in a 4. Okay, let's continue. When n ends in a 5 and cube ends in a 5. Okay, let's continue with first principles. So we already discussed when n ends in 1, 2, 3, 4, and 5. Let's continue. When n ends in a 6 and cubed n ends in 6. When n ends in a 7 and cubed ends in a 3. When n ends in 8 and cubed ends in a 2. When n ends in a 9 and cubed also ends in a 9. When n ends in a 0 and cubed ends in 3 zeros. Okay, let's continue. Now let's continue with the first principles here again. In other words, 1, 4, 5, 6, and 9 and 0 repeat in cube ending. So If a number ends in 1, 4, 5, 6, 9, and or 0, its cube also ends in the same digits. Okay. When n ends in a 2 and cube ends in a 4, and when n ends in 8 and cube ends in a 2, where 8 plus 2 is equal to 10. Similarly, when n ends in a 3 and cube ends in a 7, and when n ends in a 7 and cube ends in a 3, where 7 plus 3 is 10. Let's continue here. Each block of 3 digits or part thereof results in one digit of cube root. So, okay, each block of 3 digits or part thereof results in one digit of cube root. Let us continue here. First digit of cube root would be obvious from the first block of the cubes. So, first here is leftmost. So, first digit of the cube root would be obvious from the first block of the cube. Okay, and last digit of cube root would be obvious from the last digit of the cube. And last here is rightmost. Let us continue. Now continue with first principle still. Okay, from these we can quickly determine the first digit, which we call f, the last digit denoted by L, and the number of digits denoted by n of a resulting cube root. So if there is we have a perfect cube, we can determine first, last digits and number of digits of that cube root. Let's continue here. So for example, cube root of 226981, two blocks of 3, so n is a 2, 226 is uh, between 6 cubed and 7 cubed. 6 cubed is 216 and 7 cubed is 343. So f is a 6. From this last digit 1, last digit of the cube root is 1. Let's continue here. So for cube root of 4, 6, 5, 7, 4, 6, 3, first digit of the cube root is 1. 4 is between 1 cubed and 2 cubed. 2 cubed is 8, 1 cubed is 1, and 3 is, uh, when digit ends in 3, its cube root ends in 7. Okay, so last is a 7, and number of digits in the cube root is 3. Let's continue here. Let's look at another one. 83, 453, 453. So first digit is 4 because 83 is between 64 and 125, and from 3 here last digit of the cube root is 7, and number of blocks is 1, 2, 3. That's number of digits in the cube root. And for cube root of 6, 705, 293, 668, 793, 1, 2, 3, 4, 5 blocks. So number n is 5. The 6 is still between 1 and 8, so first digit is 1 and last digit is 7. For cube roots of 91, 003, 3553, 992, we have 4 blocks. Leftmost is between 64 and 125, so left digit is 4, right digit from 2 is 8, and number of digits is 4. Let's continue here. So first digit is 4 and it's 8, last digit is 8, and number of digit is 4. Let's continue. Let's continue to the next section, and next section is by observation. Let's continue here. Let's see how do we compute a cube root of a perfect cube by using observations. Let's continue here. This is my by observation slide, and first thing I do is write down my first 9 cubed. Okay, 1 cubed is 1, cube of 2 is 8, that of 3 is 27, and so on and so forth. 9 cubed is 729. I did not write 10 cubed is 1000, which is also part of the cubes I need. Okay, let's continue here. Okay, first is for cubes in this range, 1 cube of 1 to cube of 99. are, that would be in 1, 2, 9, 7, 0, 2, 9. Perfect cubes in this range, we can determine cube root by observation. Let's continue what I mean by. Let's look at here 6 digits here 3, 5, 7, 9, 1, 1, and we would find this is a perfect cube, and we would find a cube root using observation. Observations are my table on the left. Okay, from 1 here I'm going to use a rightmost digit. This units place 1 is tell me cube root have a 1 in the units place. So we'll get a units place of cube root is also 1. Okay, let's continue here. Then 357 here is between 7 cubed and 8 cubed. 7 cubed 343 and 8 cubed is 512. So left digit tens place digit of the cube root is 7. From 357 in the left group, left digit of the cubic root is 7. So cube root of 357 911 is 71. Let's continue here. Cube root is 71. That's another example here. Cube root of 185 193, from 3 in the units place I got a 7 in the units place for cube root. Okay, let's continue. Left digit is 5. 185 is between 125 and 216. That's 5 cubed here, 6 cubed here. So it's a 5. Right digit is 7. 57 is the cube root of 185. We use this table, and this is my results by observation. Cube root of 185 193 is 57. Let's continue. Let's do some exercises here. Determine cube roots of the following perfect cubes. Let's continue here. That of 3375, cube root of 3375, cube root of 238, 328, cube root of next exercise is cube root of 5832. Next is cube root of 140608, and some more. Let's continue here. Next section here. Okay, now we would discuss, we would extend the observation table. We use the first 10 cubes. Now we would extend that a little further, have more entries in my cubes table. Let's continue here. Now we will extend the observation table, which is the table of the cubes. So let's continue here. This is the table we used before of first 10 digits, cubes of first 10 numbers here. Okay. Okay, next we do in cubes of next 10 numbers. 11 cubed is 129, 13 cubed is 2197, 6 cube of 16 is 4097, that of 19 is 6859, and so forth. Let's continue. And then I have two more cubes, which is 21 cubed is 9261, and 22 cubed is 10648. Okay, let's continue and see how we can use these extended table. Okay, here's example. Here's my extended table here. First 10 I did not list. First cubes of first 10 numbers I did not list here. I just listed the next 12 cubes of next 12 numbers. Let's see how do we use this extended table now. Okay, here's my example. Cube root of 10218 That's about 8 digits. Okay. Leftmost digit is 10218, which is between these two cubes. That means 21 is my left digit. Okay. Right digit is 3. From 3 it is 7. So cube root of 10218 is 217. Let's continue here. So that's cube root here. Another example here, cube root of 5451 776, that's 7 digits. Okay. from leftmost 5451, that's between 17 and 18 cubed. Okay, so that 17 is leftmost digit. 6 from 6 on the rightmost digit, I have a 6 in the rightmost digit of the answers. So it is left digits are 17, right digit is 6, and cube root is 176. Do some exercises. Find the cube roots of the following. Let's continue here. First example is 4826809. Next is 4410944. Next is 3176523. Next is 2197000. Let's continue. Is 5000211 and some more. Okay. Let's do next section here. So we would now look through by divide and conquer. How do we compute cube root of a perfect cube using divide and conquer? Let's continue here. So we would do this thing here. First we will note some observations we'll make. If a perfect cube is even, its cube root has to be even. We should be able to extract factors of 2. Okay, even cube root. Okay, so example I take is cube of 12 is 1728. That's right in the table. Okay, and which is equal to 2 times 864, which is equal to 2 times 2 times 432, which is equal to 2 times 2 times 2 times 216, and this 216 is a 6 cubed. Okay, so this is a 2 here, 2 cubed here, and 6 cubed here. That means that it is equal to, then we could keep continuing, 2 times 2 times 2 times 2 to 108, and we actually know 6 is a cube root of this thing, but let's continue. So then we continue to some more, 54 here. Yeah, now we say 2 times 2 times 2 times 2 times 2 times 27. Cube root 27 is 3. Let's see what we did here. So is cube root 1728 is from 2 cubed is a 2, another 2 cubed is another 2, and this is 3 cubed. This is 3, it's 12. Okay, so we just did divide and conquer. We just divided them into smaller factors, and then we, from each group of 3 factors multiplied together, we pick up one factor, one term in the cube root. So let's continue. Now next observation we make, if perfect cube is divisible by 9, we should be able to extract factors of 3 times 3 times 3. So if a perfect cube is divisible by 9 or 3, then it should be divisible by 27 also. So an example is 23149125. Let's continue here. So digit sum of 231492125 is 9. That means this number 23149125 is divisible by 9 and also by 3. Okay. So 231492125 is 3 times that number, 7716375. Then another 3 times 3, another factor, 25722125. Then another factor, 3 times 3 times 3 times 857375. Then make cube root of, and okay, the 370, so we is here, we got 3 outside, and cube root of 857 and 375. From here, right digit is 5, and from here, left digit is 9. Okay, so cube root is 3 times 95, which is 285. Let's continue here. So cube root of 231492125 is 285. No, yeah, cube root of 231492125 is 285. Let's do some more if observation. If a perfect cube is divisible by 5, we should be able to extract factors of 5. That means the cube root is also divisible by 5. Okay, that's what we're trying to make statement here. Okay, let's continue here. Example, you take example of cube root of 2460375. So cube is divisible by 5. So let's see what we do here. Then we are trying to extract out at least 5 times 5 times 5 as factors. So that's equal to 5 times 4, 92075, which is equal to 5 times 5 times 98415. Okay, that's equal to cube root of 5 times 5 times 5 times 19683. So that's is equal to 5 times. Then we start taking 3's out from here because this is a divisible 19683 is divisible by 9 and also by 3. So we start taking 3's out from here. So it's a 5 times cube root of 3 times 3 times 2187 6561. When I extract out a factor of 3, I got 2187. Then we continue. That's 3 times 3 times 3 times 729. Okay, 729 is a cube of 9. So it's 9 cubed 729. Let's see what we did here. So it's 3 times 3 times 5 times 3 times CR, 5 here and 1 3 from here is and also CR, cube root of 729, and 729 is 9 times 9 times 9. Okay? So that's equal to 5 times cube root is 5 times 3 times 19. Okay? 15 times 9 is 135. Let's continue. Okay, let's do the next section now. In this section, we would start using polynomials here for the cubes. So we would take a polynomial, take its cube, and use that cube of the polynomial to compute the cube root of a perfect cube. So first polynomial observation, we can represent a decimal number by a polynomial in x, where x is 10 and all its coefficients are in the range of 0 and 9. Okay? So their coefficients are 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Let's continue here. Initially, we will use this polynomial here, c times x squared plus b times x plus a, where a, b, and c are in 0 through 9, and x is equal to 10. Okay, let's continue here. So if I did a cube of that, coefficient of x6 is c cubed. X6 would come from this term here. That x5 is 3bc squared, and x5 would come from these two terms. Square of that and bx multiply once. Okay, so that's what give me cube, and then from all the combinations I get a 3 times b times c squared. Okay, let's continue here. For x4, I can get x4 from square of this term or this term and square of that term. Okay, so it's a 3a square c squared. That's my one way to compute x4, and this is the c and b squared here. Okay, so that's b squared here, and from the combinations I got it 3 times that. For x cubed, I can get x cubed from cube of this number here, b cubed, that's right here, and also can get a multiply uh, CBA. So that's A, B, C here. So if it's CX squared plus BX plus A is also a cubed, so that would give me 6 times A times B times C using all the combinations we have. So x squared comes from this term multiplied by that term, which is a C, right, this term here. 3 is from the combinations, okay, or you can get square of that, which is this term here, and this is constant terms. And coefficient x1 would come in from multiplying this number term bx by square of that. Okay, that's a square b, and there are 3 such combinations, so we have 3a squared b. Okay, and x0, which is constant term, is we get from a cubed only. A times a times a is my constant term. Let's continue. Example, we would use a 127 263 527 cube root of that as, for example, to use solve by cubes of polynomials. Let's continue here. So I have this coefficient x cube from the previous discussion is 6abc plus b cubed. That of x square is 3a square c plus 3b square a of x power 1 is 3a square b, and of the x power 0 is a cube. Let's continue here. Example. So that's the example. Cube root of 127 263 527. We know that a is from here 3. Okay. Left is 5 from here. It's just more than 125. Right digit is 3, and number of digits, there are 3 groups of 3 are part thereof, and that's the number of digit is 3. Okay. So we'll units place, we have a is 3. So a is units place, and that's 3. We come from right here. Its contribution is a cubed, 27. Now we go tens place number is this number minus 27. So minus 27, I got in it 127 263 5 and 2 zeros. Okay. Now we are dealing with tens place number, and we don't need a one number on the units place. Okay. So we just cross that out. Okay, now that is a x1 is 3a square b, and which would end in this term 0. Okay, that means a square a is 7, so 3 times 7 times 7 times b ends in 0. This 0 right here. That means that 147, 7 times 7 is 49, 49 times 3 is 147. It ends in 0. Okay, that means b is 0, and its contribution right here is going to be 0. Okay. So b is 0. So we got one more digit here. 100 place is number is this number minus 0, and I would need to cross out one more digit here. I'm now working on 100th place. Units and 10th place we have already used, so we'll start working with the 100th place digit. Let's continue here. So that means 3a square c, which is that one, plus 3b square a, that one ends in a 5. This is the digit 5 here. Okay, so far this what we had. Okay, so that means 3 times 3 times 3, a is a 3 right here, times c is 3 times b0 and times 3 ends in a 5. Okay? That means 27c ends in a 5. That means c is 5, which is what we had before, so it confirms. So cube root of 127 263 527 is 503, and we use these polynomials, cube of a polynomial, to find these values out. Let's continue. This example here, cube root of 128 024 064. First note that cube is even, so is a cube roots. Okay. First of all, left digit is 5, and right from here, and right digit is 4 from here, and number of digit is 3. Right digit is 4, left is 5. Let's continue here. Extract out the factors because this is even number and so is a cube root is also even. Okay, so we divide by 8. Okay, and that gave me 016003008, and this is also a even number, so we'll extract out another 8 here. Okay, so 002000376, that means the 8 is it's still even. We will extract out one more 8 here, so it's a 900250047. So this is not a even number anymore, but it's divisible by 9, so we'll extract out 9 here. So that gave me a 000027783, and this is still divisible by 3, so we'll extract our 3 here, and that number is 9261, and that's divisible by 9, so we'll extract 1 9 out here. That gave me 001029, that's divisible by 3, so we'll extract 1 3 out from here, so get 000343. Okay, that means that here's 8 cubed, so 8 is a factor of the cube root. Here's the 27 times 27, that means a 6 is another factor, 3 here and a 3 here. So 8 is 1 cube here, cube root. Another factor is 3 times 3, and then cube root of 343 is 7. Let's continue here. So then the cube root of 12A024064 is 2 from here, 2 from here, 2 from here, 2 times 2 times 2. From here I got a 3, and from these I got a 3, another factor, 3 times, and times the cube root of 347. 2 times 2 times 2 is 8, and 3 times 3 is 9, and a 7 from here. 8 times 9 times 7, which is 72 times 7, which is 504, and this matches our observation here. Leftmost digit is 5, rightmost 4, and in the middle I got a 0. Continue, and we will use the cube polynomial, which is dx cubed plus cx squared plus bx plus a. Okay, let's continue here. Cube of that term polynomial is dx cubed plus cx squared plus bx1 plus a is coefficient x cubed will come from this term and multiply twice with this one. So a cubed 3 times a squared from here and d here. Okay, and also we can get those from bx times bx, that's that one. We also can get a cube from multiplying cx squared plus bx plus a, so that gives me 6abc. Let's continue here. For x squared term we can get cx squared and a squared here, that's this one here, a squared c, the 3 of those. Okay, and we can also get a square of x and a, so that give me b square and a, and there are 3 such groups. Okay, of ax power x we will get from multiplying b with a squared, that's 3a squared b, and for x0 we can only get from a times a times a, and that's a cubed here. Let's continue here. We do not use the coefficients of x power 6, x power 5, and x power 4. Let's example of cube root of 4, 314, 825, 152. There are 10 digits here. Okay, let's continue here. And this is my cheat sheet. Coefficient of x cubed is 3a squared d plus b cubed plus 6abc, and that of x squared is 3a squared c plus 3ab squared, and of x1 is 3a squared b, and for x power 0 is a cubed. Let us continue here. So left digit is 1 from here, and rightmost digit is 8, and number of digits is 4. 1 group, 2 group, 3 groups, and a 4th group. Okay. We will first, this is even number, so we will first reduce that. We'll divide that into a smaller cube root problem. Okay? So that is a even number, so we'll extract out 8. 8 times 5393, 53144. You can extract, start dividing by 2 at a time if you care to. So this is also even again, so we'll do that again. We'll extract out one more 8 here. 699194143. Okay? Okay. Now we got in a cube root of that number is equal to 64 cube root is 4 times cube root of 69 919143. Let's continue here. So now we have left is 4 here, right is 7 from here, and number of digits is 3, and we will multiply that by 4 when we get down. Okay, let's continue here. So unit place is 7 right from here. Its contribution is a cubed, which is 343. Okay. Okay. So we continue here, and we have a 7 here, and middle digit we don't know. 4 is the left digit we know, but we're trying to confirm that. Okay, let's continue. Tens place number is now 699194143 minus 343. Contribution from 7 was a cubed, was 343, and so we are going to subtract that here. So that's giving me 69918 and 800, and we are working on tens place, and units place we have already used, so we cross that out. Let's continue here. That means this is my tens place is this number here, 3a square b, ends in a 0 right here, which is 3 times 7 times 7. A is 7 times b ends in 0. Okay? That means that 147b ends in a 0. That means that b is a 0. So this question mark here, we just solved that to be 0. I'm going to continue here. So far we have gone that far. Okay. Now we go hundredths place. Number is 69918 and 800, and we would subtract 0. Okay. So which already did, and we cross hundredths place. We cross out the 2 digits, and 108 is this hundredths place here. 100 place is x squared here. That means 3a squared c plus 3ab squared. 3a squared c plus 3ab squared ends in this 8 here. Let's continue here. A is 7. So 3 times 7 times 7 times c plus, because b is 0, so this is 0. Ends in 8. That means 147c. 3 times 7 is 21. 21 times 7 is 147. Ends in 8. That means c is 4. So this we just confirmed that this number is really 4. That tells me that my other 0 must be right also. I must not have messed up the computation of 0. Let's continue. Then my cube root of 4314825 is 4 times 407, which is 1628. Do example of cube root of 8364294194448. Now we have a 12 digits. It's a perfect cube here. Okay, let's continue. So this is my cheat sheet here, and these are my coefficients of the cubed polynomial. Okay, and so left is 9. This is 836. 9 cubed is 729. So this is more than that, 839, and right digit is 2 here from 8, and number of digits is 4. One group, two group, group number 3, and group number 4. Number of digits in the cube root is 4. Now this is even number, so we should be able to extract out a factor of 8. So 836429419 448 is 8 times 104553677 Okay, so it's not even anymore. Okay? So cube root of 8 given number 8368429419448 is 2 times cube root of 104553677 That's 2 times cube root of 104553677 Let's continue here. So left digit from here is a 4. Okay, 104 is between 64 and 125. A right digit is 1 from here, and number of digits is still 4 because this is one group, second group, third group, fourth group. Let's continue here. Unit place is a is equal to 1. We just found that its contribution is a cubed, which is 1. Okay, let's continue. The 10th place number is, we'll start with this number here, we'll subtract 1. Okay. That gave me 104, 553, 677, 430. We are dealing with 10th place and we already used the unit place here, so we crossed that out. Let's continue here. That means 3a square b ends in this 3 here. So that means 3b, a was 1. A is 1, so 3b ends in a 3. That means b is 1. Okay? That means, and its contribution is 3 because a is 1 and b is 1. 1 times 1 times 3 is 3. Okay? So we'll subtract out 3 from here, and we so far we have got a 4. We know it is, but we want to very confirm. And this hundredths place we are going to find right now. 2 digits on the right we have already figured out. Okay? So when I subtract 3 from here, it gets me, I'm going to subtract 3 from this 3 here. Okay? I get it 2 zeros at the end, and we already used the units place and tenths place. We are now going to use the hundredths place. That's 4 here. So cross this out. So that means I'm on x square now, 100, this term 3a square c plus 3ab square must end in as 4 here. Okay? A square c plus 3ab square ends in a 4. So a is 1 and so is a b is 1, so that means 3c plus 3 ends in a 4. Okay? That means 3c ends in a 1. Okay? That means c is 7. Okay? Contribution, so 7 comes right here. Contribution for that is 24. This is 21 plus 3. Okay? Let's continue here. Now we know 7 here. Now we turn to work 1000 place. It should better come out 4. Okay? Okay, now we subtract 24 from here. We subtract 24 from 74 here. Okay, so that comes in again 104, 553, and 675, and 3 zeros. We are working on 1000 place. We have already used the rightmost 3 digits, and we crossed that out. Now we are working with the digit 5, which is in a thousands place. A thousand is, this is my coefficient for x cubed term. Let's continue here. So we are working with thousands now. That means that this 3a square d plus b cubed plus 6abc. 3a square d plus b cubed plus 6abc ends in 5. Let's continue. A and b are each 1 and c is a 7. A is 1, b is 1, c is a 7, and d we have to find out. Okay? That means that 3 times 1 times d, so 3d plus b cubed is 1 plus 6 times 1 times 1 times 7 ends in 5. So this is a 42. This is 1. That means 3d plus 43 ends in a 5. That means 3d ends in a 2. That means d is a 4, which confirms. D is a 4 and it confirms here. Okay, that means cube root of 836429419419448 is 2 times, that's here 2, times 4711, which is equal to 9422. Okay, let's continue. Now let's do some exercise here. Find the cube roots of the following. First is 498865935491. Next cube is 463139882168. Next cube is 42399022303, and some more. Some references here. First reference is my teacher's manual, teacher's manual 1, which is by Ken Williams, and you can get the PDF form for free and print form for purchase from Vedic Maths site, vedicmaths.org, which is Vedic Math Academy's site. Let's continue here. Now then, Tirthaji's book, and which is a main reference for the use of polynomials and also by observations. Okay, continue here. Vedic Math for Schools is 3 volumes, has covered most of the topics in Vedic Math. It's a Glover's book, and he uses these books in his school. Let's continue here. And Vanna Singhal's book covers most of the topics in Vedic Math. And then it's Bhatia's book, and that is has a very quite a few collections of decent examples of the by observations. Okay? Cube root by observation, and that's it.